In fact, let's take calcium. Okay, so now this is solid, this is aqueous, this is liquid, and this is also aqueous. Now here's the thing. Let's first see, will this be white or colorful? Calcium oxide.
White.
White, yes, it will be white. And it's a solid. So you will see a white solid. This one is an acid. All acids are colorless. So you will not see anything. Colorless. Water is colorless, so you won't see anything. This one is colorless as well because it dissolves. Look at the state. It is aqueous. So it's colorless, it dissolves. Now tell me, will you see something appear here? Is there anything in here that will show up? Like some bubbles or color or anything in the product side? No, right? बताएं मुझे आपको समझ आ रही कि नहीं आ रही? So this one, we can see no color is coming out. So we will not see a change. Imagine something completely going colorless. Does anything appear? No, it's colorless. But does anything disappear? Yes, the white solid disappears. So when something disappears, then you have to focus on that thing. So there are two ways of looking at it. If this is disappearing, then I can be like, okay, I can measure the color. I can measure the color. Okay, so I can measure the time taken and the color for how long it passes. So it will be difficult to make a graph of this. Yeah, but I can make a table that I can be like, okay, I'll do this reaction 5 times. Okay, so this is 1, 2, 3, 4, 5. And I'm going to measure the time taken for it to disappear. Right? I can do that. I can be like, okay, how long does it take for it to disappear? So I can be like, okay, first time it's 20 seconds, second time it's 20.2, then it's 19.7, then it's 19.8, and then it's 14. So if somebody does that, will you accept all these values? Or will there be a value that will be like, oh, this doesn't belong here? Can you pick an odd one out? Me, come on. Is there a value here that doesn't seem like it belongs?
Fifth one.
So first one is 20. The other one is similar to that. The other one is also close to that. The other one is also close to that. And this one is really off. 14 is very off from the general trend. So you'll be like, 4 दफा 20 के पास हुआ है तो ये 14 क्यों है? ये तुमने गलत किया होगा. That is the easiest explanation, that you've done it wrong. Either you've done all 4 wrong or you've done this one wrong. So most likely this one is wrong. So you'll be like, okay, do this again. And that is why we repeat it. Because if you repeat, you're less likely to make mistake. You can average out the values. So in this situation, we were just figuring out that how soon does it disappear. So that is one other method of looking at the change with respect to time. Remember, all rate of reaction is change with respect to time. Here I was measuring the change in volume of gas with respect to time. Here I'm measuring the change. What's the change here? White solid disappearing. And what's the time? The time taken to do that. You might, similarly, there's another example I'll give you. So for example, yeah, let's do this reaction. Let's say I have this reacting with this, not this, this, to produce. Now let me put the state symbols. Okay. Now, judging by the state symbols, can you tell me, will we measure appearance or disappearance? Will we see something disappear or will we see something appear? Yes, can you say that again? Sorry.
Appear.
Appear. Very good. We will see this showing up. We will see the calcium carbonate appear because it's a solid that will come out. So that solid is called precipitate, by the way. Precipitate. So in this situation, the easiest way to look at this reaction is that, okay, I will do the reaction in this thing. I will put this on top of a piece of paper. So this is where the reaction is happening. On this piece of paper, I have a cross. So when I look at it from here, from the top, after a while, the cross will disappear, right? Because the solid is going to come out and it's going to cover the whole thing. So after a while, I will not be able to see the cross below this reaction thing, this test tube. So I will know that reaction has completed. So in this one as well, you can draw a table. And in this table, you'll be like, okay, the time taken for the cross to disappear. Why? Because either you measure the time taken for white to appear to a certain level, but that's colorimeter. We don't do it in O levels. We usually do it in IB, but not O levels or IGCSE. But you can be like, okay, I do this reaction 5 times. I measure the time taken for this cross to go away, that I'm not able to see it when I look at it from the top. Okay. Now I'm going to show you some methods that we do in the lab to see how the reactions happen. Okay. So I have calcium carbonate and I reacted with HCl. Now, when this reaction happens, calcium chloride, carbon dioxide, and water is produced. This is a gas, this is a liquid. Now, can you look at a thing that will disappear in this reaction? Can you tell me what will disappear in this reaction? Remember, things that disappear are always at the start of the reaction. Reactants में से. This is aqueous, this is colorless, this won't go away. But this is solid. It will disappear. It will dissolve. Is that easy to track? You saw here. It's not that easy to track. यहाँ पे भी हमने देखा था. It's not easy to track क्योंकि उसमें टाइम देखना पड़ता है आपको कि कितनी देर बाद वो खत्म हो गया. आपका रिजल्ट और होगा, मेरा रिजल्ट और होगा, किसी और का रिजल्ट और होगा. क्योंकि people see things differently. Our eyes also deceive us. हमें लगेगा कि हमें नजर आ रहा है, हो सकता है हो ना. But look at this one. Do you have something that will appear? This is aqueous, colorless. It won't appear. This is gas. Bubbles will appear. Much easier to check, right? So in this reaction, the easiest method is the first method that we saw. Volume of gas. Because you are seeing something that will appear. So the point I'm trying to make is that you can have many things that will appear or disappear in a reaction. You have to pick which one is best, which one is easiest to track. So in ATP, when you have to design an experiment, look at what appears, what disappears, and see which one's easiest to pick. Now, I'll show you 2 examples of what we usually do. In case a gas is coming out, there are 2 easy ways of looking at it. One is the volume of gas compared to time. So after a while, you will see that you will create a table. In this table, you will put time here, volume of gas here. That okay, after 10 seconds, at 0, it's 0 volume of gas. After 10 seconds, it's something 2, for example. After 20, 30, 40, 50. Let's do it. So you can see over here that I got this value. Now I plotted it on the graph. So I plotted the points here. And then I joined them. When did it stop appearing? When did it stop coming out? Look at the table and tell me. Here. After 40 seconds, no more gas is coming out. The value is increasing until 40 seconds. And after 40 seconds, the value is same, which means the reaction is complete. So that's another thing about rate of reaction, that once the value starts to repeat, it becomes constant. We will know that reaction is complete. So reaction is complete because value becomes constant. Now we can track another thing here. Because a gas is going out, we can track it another way. We can measure the mass of the whole thing in grams, for example, with time. Now we'll draw a table again. On this side we have time, on this side we have mass. Can somebody tell me, will the thing have higher mass before the reaction or higher mass after the reaction? I'm talking about the beaker or the container in which I do the reaction. Will the mass increase or will the mass decrease?
Stays the same.
Why should it stay the same?
Like the reaction is complete, so
What do you mean?
like if a reaction is complete, there won't be anything more produced, so it will stay the same.
Yeah. So here's the thing. The total mass stays the same here as well as here. The total mass does not change. But because a gas is going out of the reaction vessel, when you do the reaction, you let the gas out.
Or less.
So the mass will decrease. So when you do this, you will obviously get different values of time. So the mass will decrease. So maybe it's 50 grams initially. It goes down to 48, 45. No, actually, that's wrong. It won't happen that way. Let's say 47, 45, 44, 43, 43, 43. So when is the reaction complete here?
40.
40 seconds. Yes. 40. Yes. Okay. So yes, the value is repeating here. Now, when we draw this, we will see a graph that goes like this. Notice two things here. One, the graph does not, the value does not become 0. The graph does not go like this. Why? Because only the gas is gone out. This is still there, this is still there, and if something extra was added, that is also still there. So it will never go down to 0. So in MCQs, they always give you these graphs and they're like, okay, is this one correct or is this one correct? So we pick the one that is correct, the one in which the value doesn't become 0. Why? Because the mass will never go down to 0. Not all of it is going away. Clear? So what we have seen so far is methods of tracking rate of reaction. We just look at what appears and what disappears. If you have something that disappears, like a cross mark, because a solid is coming out, then you can easily measure the time taken for it to disappear. If you have something that disappears like a white solid, then you can use a colorimeter to track that. Colorimeter. And colorimeter will tell you that, okay, this is the time taken for the solution to just disappear. Similarly, we can measure the appearance. So we can measure if a gas is coming out, we can measure the volume of gas, that, okay, how much gas is produced after a while. So a basic setup of this might be like, we do the reaction here, we connect it with a gas syringe, and gas, always measure point in this one, graduations. These graduations are important. If you don't put them there, then you will not be able to measure them. So always, if you're drawing the diagram, put these marks there. Okay. What is wrong with this setup right now? Can somebody tell me?
There's no cap to block the
There's no cap.
gas.
Very good. So there has to be a cap because we want to stop it. So stopper is required. So when you label it or when you draw it, make sure you do it. And of course, this one, I'll just heat it. No need to draw heat source. Okay, so always mention just heat. Examiner doesn't ask you to draw heat source. Okay, all right. So these yellow things that I'm putting in, these are important for not losing marks. Okay, so now we have seen how we can measure the rate of reaction. We just look at the equation. We see if something is appearing, we measure that. And if something is disappearing, we measure that. Okay? Yeah. And now the next thing is to figure out, looking at different reactions, what is the best way? One method is you see the gas and you collect the gas. One measure is you see the solid which is disappearing, you use the colorimeter. One method is you see a solid that is coming out, that is appearing. You use a cross and you look at the time taken for the cross to like stop being visible. One method is you measure, we have seen this one. One method is you measure the mass of the thing. So the diagram for this might be this way. That you have this reaction happening here, you put it on the balance. So this is the balance. And you put cotton wool. Always put cotton wool. This way, air or air particles will not dissolve into the other particles in the air. Okay, so this will show mass going down. So we have seen 4 methods of looking at rate of reaction. And the last method that we have, that is titration. But titration, rate of reaction, titration, pH, these rates of reaction, they don't ask us for those in O-levels and IGCSE. But you can still track them as well. You can use a pH meter to see, okay, how soon does the pH change? And you can figure that out. So does everybody understand how to set these up for the exam? How to draw the table, how to draw the graph, how to draw the setup? These 3 things are important for your ATP. Any questions on this? No? Okay. Last thing. How do we measure rate of reaction? We look at the graph. So the gradient of tangent shows rate. Okay. Of course, I'm making sure that you have volume with respect to time or mass with respect to time or something with respect to time. And that is showing you the rate. So a higher gradient, like if it goes like this, so that is showing high rate. And if it goes like this, that is showing low rate. So this is lowest, this is highest. Okay. So the more steep it is, the more the rate. So for example, if you look over here, the rate is decreasing. Just draw the tangents. If you look over here, the rate is decreasing because it's becoming less and less steep. And that shows how the rate progresses. So it's fastest in the beginning. So that's another important thing. Rate is fastest in start of reaction. Okay.